Hello there, welcome to this video on acceleration. Okay, so in the last video on speed time graphs, I introduced you to a quite unusual unit. And that unusual unit was meters per second squared. That's quite strange. It's not like anything you've come across before. And essentially, meters per second squared is the same as saying meters per second per second. Trouble is that also sounds quite odd, so let me try and explain it. Have a look at this table. Each second, the speed is going up by 5 meters per second. It goes up 5, it goes up another 5, and so on and so forth. So, it is increasing by 5 meters per second per second. Okay? It's kind of strange to get your head around. So it's going up by 5 meters per second every second, or 5 meters per second per second. And that's like saying 5 meters per second squared. So that's where that strange unit comes from. It doesn't matter, it's not going to come up in your exam, but why that is the way it is, but I think it's important that you know it. So there you are. So now there are two equations that you might use for acceleration. Now the first is change in speed over time. Now you can write this using symbols as well. A equals v minus u over t. A is acceleration, v is your final speed, u is your initial speed, and t is your time. So if you said my car does 0 to 100 in 10 seconds, then the 0 to 100, that's v, your final speed was 100, u, your initial speed was 0, and your time was 10 seconds. So let's have a look at a question that uses this. So a brick is dropped from the top of a building and hits the ground at 20 meters per second. It travels for 8 seconds. Calculate the acceleration. Right, okay, what do we know? That's the question you ask yourself in here. What do we know? Do we know v? Yes, we do. We know the final speed. It was 20 meters per second. That's the speed it was doing before it hit the ground. That must be its final speed, so v is 20. Do we know u? Do we know its initial speed? Well, it's kind of implied in the question. It's a bit sneaky, but it's implied in the question. A brick is dropped from the top of a building. So this brick was in someone's hand. And for a moment, it must have been stationary. So u, we shall suggest, is 0. And exam papers do this sometimes. They imply that it's 0. So 20 minus 0, 20 minus nothing, that's 20. Do we know t? Do we know the time it took? Yes, we do. It travels for 8 seconds. So it's 20 over 8. 8 into 20, go 2.5. 2.5 meters per second squared. This means this brick got 2.5 meters per second faster every second. Okay. Now, if we look at the second equation that we need to use for this, it's a rearrangement of Newton's second law, which is F equals ma. Rearrange that, you get A equals F over m. Acceleration is force over mass. Now, let's look at a question. A truck has a mass of 2,000 kilograms. The driving force created by the engine is 3,000 newtons. Calculate the acceleration caused by this force. Well, it tells you the mass and it tells you the driving force. So it's force over mass. A equals F over m. Force is 3,000, mass is 2,000, so it's 1.5 meters per second squared. So really, all you need to do with either of these two equations is just choose the right one. If the question gives you the force and the mass, do this one. And if the question gives you the start speed, the finish speed, and the time, use the other one. And that's all there is to it. Let's talk about relative velocity. So here we've got a man standing here looking at these two trains. We've got an express train doing 60 miles per hour in this direction, and the local train doing 35 miles per hour in the same direction on a parallel track. So this guy here sees this one doing 60 miles per hour and this one doing 35 miles per hour. But here's my question. If you were on this train and the express train overtook you, how fast would the express train look to you? Now you're already doing 35 miles per hour. So what you do is you just subtract that from here. That train is going to look like it's doing 25 miles per hour. It's going 25 miles per hour faster than you. So it's going to look like it's doing 25 miles per hour. Okay, so to this guy it looks like it's doing 60. To a passenger on this train, it would look like it's doing 25 miles per hour. And that's relative to velocity. It's fairly sort of common sense. What about if they're doing opposite directions? This time this train's going this way and this train's going in the other direction. That's a different story. So again, this chap here, he sees this one doing 60 miles an hour this direction, this one doing 35 miles an hour in this direction. But if you were on this train looking out the window and you saw this train fly by in the opposite direction at 60 miles per hour, what speed would you see it going at? Well, you add the speeds up. Because you're going in the opposite direction, you have to add those speeds up. It's going to look even faster because you're going in the opposite direction. So your relative velocity there is going to be 95 miles per hour. So in the first example, you subtract one speed from the other, and in this example, you add those speeds up. But like I said, that's fairly sort of common sense. We sort of see that quite a lot in our everyday lives. Okay, let's finally talk about something called vector and scalar quantities. A scalar quantity has a magnitude. Now, what's a magnitude? It means it's a number. It's a number telling you the size of the quantity. So if it's mass, how big is this mass? It's 20 kilograms. Is it 50 kilograms? Is it 70 kilograms? So magnitude is a number. 80 degrees. 80 degrees C, 80 degrees Fahrenheit. It's a number telling you the size of the quantity. A vector quantity has a magnitude as well, but it also has a direction. So for example, 20 meters per second north. 20 meters per second, that's your magnitude. North, that's your direction. So these vector quantities here, they don't only have a size, they also have a direction. Let's have a look at the acceleration equation that we met earlier on. A equals v minus u over t. Now v is velocity. And if you remember just now, velocity is a vector quantity, and that means it depends on direction. Speed does not depend on direction. If you're doing 20 meters per second, you're doing 20 meters per second. It doesn't matter if you're doing it in a straight line or if you're doing it round a corner. However, velocity depends on direction. If you're changing direction, then you're changing velocity. So, let's say this arrow here, this vector here, this is 20 meters per second upwards, northwards. And suddenly, we are going to change the direction. It was doing 20 meters per second the whole time, but because it changed direction, it changed velocity. And because it changed velocity, it changed acceleration. So acceleration is a vector quantity too. Let me give you an example to try and sort of make that a little bit more sensible. Here we have something called a centrifuge, a human centrifuge. Now this thing is used to get pilots and astronauts used to extreme acceleration. Now when it spins in a circle, so it's constantly changing velocity because it's constantly changing direction. Even if it was going around at a constant speed, it is constantly changing direction. So it's accelerating. It's in a state of constant acceleration. So the pilot, the trainee pilot or the trainee astronaut is experiencing a constant acceleration. G's, how many G's is this person experiencing? 2G, 3G, 4G, and that's what the acceleration is. Now, what you can do with this is if you've got a spinning space station or a spinning spaceship, you could produce artificial gravity. You spin the thing around, it creates an acceleration, and you can produce artificial gravity this way. Right, so that's about it for acceleration. Here's some questions for you. If you pause the video here and have a go at these questions and then unpause it, and the next slide contains all of the answers. Do like, share, whatever with this video. All feedback is very, very much appreciated. Pause the video, have a go at these questions and see how you do. Good luck. Thank you very much for watching.